In the last video we talked about the factor theorem, and in this video I'm going to talk to you about what's called the remainder theorem, which should seem quite intuitive if you've seen this previous video. It's just kind of like an offshoot. But before I do, I wanted to make something quite clear. I'm not sure it came across in the last video, which is we had our p of minus 3 here because we determined that x equals 3, and we said because p of 3 is 0, then therefore we have x plus 3 is a factor there. We could have also done that with x equals minus 1, and we put minus 1 in there. Why don't we actually do that now? Let's do that. So we have p of minus 1 in here. That is going to be minus 1 squared plus 4 times by minus 1 plus 3. So that is going to be 1 minus 4 plus 3, which is indeed equal to 0, so that we can say that x plus 1, obviously change the sign from this, so x plus 1 is also a factor. And I should make it clear, no other number will work and you'll get 0 at the end. No other number will give you a 0 other than minus 1 and minus 3, because they are the only points, if we go back up here, they are the only points of intersection with the x-axis. So let me ask you a question. What do we get if we try going in at another value? If we try going in at 0, if we have p of 0, then we're going to get x squared, which is going to be 0, 0 squared, plus 4 times 0, that's going to be 0. We're going to be left with plus 3, which is going to be up here. So what it does really, if you put any number in there, is it just gives you the kind of the y value of whatever it's going to be. And the remainder theorem is kind of like an offshoot of that. So let me come down here a little bit. So I'm going to write in here the remainder theorem. Remainder theorem. Okay, so what the remainder theorem says is we want to know what is the remainder when we, let's say we divide p of x. P of x, we're going to say we want that divided by x, we'll say x minus 5. We want to know what is p of x divided by x minus 5. And that's quite difficult to do if you have, we have our, what was our p of x? Our p of x is x squared plus 4x plus 3. So we could use long division here. We'll use long division, put x minus 5 over here and say, well, what's this divided by this, and do it longhand like that. But there is a quicker way. So what we can do in our quicker way is say, right, so we have this minus 5 here like this. Again, we're going to change the sign. We're going to say, what is p of 5? What is p of 5 going to be equal to? It's going to be equal to 5 squared plus 4 times 5 plus 3, which is going to be 25 plus 20 is 45, plus 3 is going to be 48. So that is the remainder. That is our remainder when we have p of x divided by x minus 5. That should be the same as what you'll get. You'll get some quotient up here, some value of what you get, and then the remainder r is going to be equal to 48 there. So that's how we do that. That's the remainder theorem. Let's try another one. So say we wanted to do, let's go down a little bit. Let's say we wanted to do p of x divided by, I don't know, divided by x plus 2. Divided by x plus 2. What is the remainder? So it'll say in the exam, what is the remainder? What is the remainder? And it'll say in the exam as well, it'll say use the remainder theorem to find the remainder. So if you use long division, you'll get maybe 2 out of 3, something like that. They'll take off 1 mark for not using the remainder theorem if they ask for it. If they don't ask for it, you can do whatever you like. But if they ask for it, this is what they're asking for. So if you have divided by x plus 2, then we'll have p of x, p of, what am I doing there? Not p of x. We're going to have p of minus 2, p of minus 2, because we changed the sign from here, times it by minus 1. So we have minus 2 squared plus 4 times by minus 2 plus 3. And that is going to be equal to, we're going to have 4 here, let's write this in 4, then minus 8 plus 3. So that is going to be equal to minus 1. So the remainder when we divide by x plus 2 is going to be minus 1. So that's the remainder theorem. Hopefully you got that in a nutshell.